Hello there, my name's Vince from My Mate Vince, and look what we've got here, a whole pile of dehumidifiers. These were all sent back to Amazon by customers because of various different faults, and we're going to try to do them all in the one video. So it's going to be a long video, so get yourself a drink, sit down, relax, let's see how many we can get working. There's 9 in total. Will we get 9 out of 9 or will we get 1 out of 9 working? Hopefully there will be some interesting faults along the way. Let's get started. Here we have a humidifier, supposed to collect up to 3.2 litres. Looks to be brand new, yet when I plug it in, it's just got a flashing red light. It doesn't come with instructions. I'm thinking the flashing red light is to do with full water. It doesn't seem to make a difference if we put this in and out. It makes no difference. And also if I hit the power button, no difference. Timer button, or it's got these LED lights apparently that goes through different colours. No difference. Has a filter in the back here, and I've got a spare filter down there. But whether I take that in or out makes no difference. So let's take it over to the map and see why it's like this. Has the little switch gone which detects when the float has gone up when it's full of water? Maybe. There's a little sticker here saying there is a small white object stuck in the top of the tank, which is the float. And it says, which triggers the alarm with the flashing red light. Please take, so flashing red light is to do with water. Please take out the water tank, move the white object by hand to have it move around smoothly. Now, oh, I didn't even realise that came off there. So I tried this, but I just tried it from the top there, not realising this comes off. But you can see there's nothing wrong there. That moves fine. But look at this. That there, I don't know if it's fouling this. It just doesn't seem to click in. Surely when the float goes up, we should get a nice little click from some little micro switch, and we're not getting that. So let's see how we take this thing apart. Luckily there are screws around the back here. And a perfect opportunity to use my special screwdriver again, which works yet again. So let's go straight to that switch and see, is it fouling on the case or is the switch actually damaged? If it's damaged, can it be fixed? These retail for, at the moment, I can't see them on Amazon, I think they're discontinued, but there's offers on places like eBay for £50, £55, that sort of price. So this is going to be working via a Peltier plate. I presume there's going to be at least 2, maybe even 3 in this one. Right, these 2 are smaller. I don't think I need to undo them. Let's have a look. Is it going to come apart anyway? It's going to come apart anyway. Let me do those 2 up because that's for the power supply. And the power supply in this instance appears to be working. Oh, hold on a minute now. So that's there now. Oh, it's working now because I've bent it. Okay, let me see what it should be like. So I did that and I bent it. How are you supposed to take this out then? Oh, maybe you lift it like that. You bend it. Right, let's see what it's supposed to look like. You can see it's built down to a cost, can't you, by the fact that even the way that's put on is not very nice. But that's just to try to diffuse the light a little bit. It's one of those things that will light up all different colours. I just don't know why people feel the need to put them in electronics. You don't need it lighting up green, purple, pink, orange. Right, the problem I've got now is I'm not going to know how much that needs to go up because I don't want it up all the time. I mean, it looks weird like that. I think I'm going to try to flatten it back down again. I've inadvertently fixed it, I think, by just trying to take it apart. And it's got a little roller wheel to make it easy to take in and out. See, I can't have it too high because otherwise it will leak water before it turns off. But too low, I might not get the full 3.5 litres. But you know what? It's better to be lower than higher, isn't it? That might well work. Let's see now. It's clicking, it wasn't clicking before. I don't even need to get the multimeter on that. Let's just see if that's going to make a difference. Yeah, it wasn't doing that before. It was jammed. Right, so I can hear it click when I push it in, but then it goes to the middle. I think that's going to be just fine because it clicks when it goes over this bit and then goes down. So let's not put the screws in, let's just turn it on and see if that red light's gone. Excellent. Right, there we go. Result. Now, if I was to put it out a small bit, let's see if the red light comes back. There you go. See here? So now what I have to do is fill it with water and see if it actually turns off. These are the different times here. 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. Oh, that's nice. Okay. And I presume this is going to be for the lights. You're going to go different colours? Yeah. Well, at least they move very slowly, so they're not going to be like a Christmas tree in the background. Right, I'm going to fill up this with water. And then, there's no way I can do this naturally, is there? No, I'm just going to have to fill it with water until the float moves up, then see if it cuts off. Don't spill it. So I filled it up about, I don't know, 7/8, maybe less. Just until this went up, so it's not, you know, I haven't filled it past that. So there would still be probably quite a few hours or maybe even a day of collection of water. So this is the earliest time filling up with water where this has gone up. So let's see if it's going to flash red. Right, so it's working, so that's not good. So I think we need to bend that down even more. Because I want that cutting off there. Unless, of course, there's not enough strength there at the moment. Maybe I should fill it with more water because there might not be enough. The more water I put in there, the more pressure this is going to be to force up. So add a bit more. Right, we're still about an inch away from the top. Still on. Well, I don't think you can have it any more than that because otherwise when you pull it out it's just going to have more chance of leaking. So now it is flashing red. Do I leave it at that? Well, I suppose how we could know is we could weigh it, couldn't we? Because it's water. So 3,200 millilitres will be the same as 3.2 kilograms or 3,200 grams. So that would tell me then, because surely it's going to be how much water it collects and not the size of the tank. So let's weigh this and see what it's saying. Annoyingly, I dropped the kitchen scales about a year or so ago. Still just about make it out though. So in case you don't know, weight is done on water. And I mean, I never knew this until I was in my 30s, but a cubic metre square of water, so 1 metre, you can't see it in the camera, but 1 metre by 1 metre by 1 metre equals 1 tonne. Can you believe that? So when you're in the sea and you're thinking, oh, the waves are powerful when they're hitting you, that's because if you think how small 1 metre squared is, that's a tonne. So 2 of them is the same as, well, not electric cars, but that would be a huge family car. 2 of them, which is nothing when you look at the sea. It's amazing. So 1 gram will equal 1 millilitre of water. So weight is done on water. When it was designed, I think. Well, there you go. 3210. And obviously there's weight to this. So there's weight to this. So it probably does need to come down a fraction, doesn't it? Because this is going to weigh more than the 3 grams. So I'm going to just try to bend it down ever so slightly. So I'm going to empty just a little bit of this out. Right, I've just done a tiny little bit. Right, 2,900. So that would allow 300 grams for the actual plastic itself. I will measure the plastic at the end, but I kind of want that to be turning off now. That would be ideal. So if I put it in now and it's not going to work, that would be good. Right, we've got the red light now. I think I'm going to leave it at that. We are, well, you're not going to be able to see because I'm tipping it, but we are about that far away from the top. So I'm going to leave it at that. Right, so this is now empty. I'm going to put the screws back into the back, and then we'll turn it on in the other room. Not the most interesting fix, fully agree, but at the same time, somebody will use this. People buy these things, so if people are buying them, then there is clearly a market for them. Whether I agree with it or not, it makes no difference. People are buying them, and I think it's because of the cost that people are buying them. So if you were to put this on eBay for £25, I'm sure it would sell probably quite easily. And surely that has to be better than it being thrown into landfill. You could argue that why is it made in the first place? Because the peltiers, they don't work very well, but they're made. At least this one has a filter and stuff. So maybe it's cleaning the air a little bit as well. I'm not sure. Right, this has been on for about, I would say, 4 hours now, so quite a long time. And there didn't seem to be anything there. I pulled this out and I was trying to feel underneath here, and then a few drips of water came, and I thought, oh, okay, it's gathered that much. But then if you look in here, there is some here. If you put it down to the corner, you can see. So it's working. It's just extremely slow. Here we have a Monhouse 1500 milliliter dehumidifier, again Peltier style, and it appears to be working fine. I've plugged it in, it was working, I filled it up with water, and now it's gone to full. I've looked at one of these before on my Advent challenge over Christmas, and what I liked is I noticed a smiley face here, but the eagle eye viewers noticed this here. A sad face on that side. How good is that? I presume that must be intentional. Look at that. It's like the best sad face and the best happy face. Love it. Anyway, you can see if I pull this out here, that will mimic the float not being up. This is full of water here. And you can see now it's on. So I'm going to put this in the corner of the room and see if throughout the next few hours it can collect any water. So I'll empty out this and see if any fresh water comes into it. I think it's the case that people are sending stuff back like this because maybe they're not happy with the performance. And I wouldn't blame them. Compared to like a compressor dehumidifier, there will be no comparison. And Mr. Smiley has been on for about 4 hours now. So let's turn him off because I'm sick of hearing it. Let's see if it has gathered anything at all. Right, good news, I can see a drop. There's definitely a drop of water there. There, oh yeah, that's done quite well. Maybe the upstairs, this is upstairs, maybe the upstairs of my house is better for gathering water than the downstairs. To be fair, the downstairs is next to a big radiator, the other big one I did, so maybe it's drier next to the radiator. That's actually got more water than I thought it would. So yeah, it appears to be working. Now on this little fella here, you can see that the adapter has been dropped and this has come off, and I thought to myself, okay, well, not going to repair that. But interestingly, there's no voltage coming out of it, so it's more than just drop damage. And I do quite like looking at power supplies, even though they are dangerous. So I think I am going to look at it to see what has failed on it. Has the drop damage broken something else? Or what's slightly strange is this doesn't look like it even wants to fit on it very nice. It's like the capacitor is, and the capacitor is not bulging, it's just that there's no room there. So I'm not sure, because that capacitor does not bulge out because it's a new product. I'm not sure what's going on, but anyway, look carefully. I'm not touching the inside, obviously. I'm going to turn it on beforehand. There you go, we're in there now. And if I go in here, there is no voltage coming out of this at all. I think it said it was 9 volts. So if you have a look here, you can see there's nothing. So let's bring it over to the mat, try and open it. It's going to be glued, but we might be able to crack it open and see what the failure was. Right, here we go. I've got the vise here. Let's try to squeeze it and see if we can crack it along this bit here. Obviously, I'd never sell something like this on, but you would struggle to buy one of these. So if this was your own one, you might not be able to easily get one of these because of the connector at the end. Also, 9 volt as well is not going to be as common as maybe something like 12 volts. That's cracking nicely. Right, let me try to use a bit of persuasion. Now I've had this plugged in, so I've got to be a little bit careful about putting my hands in here because I don't want to get a shock. Right, this looks like it might be the low voltage side because it's 12 volts here, so I should be okay there. Just trying to bash it along the seams in the hope it might loosen up a bit. There we go, look at that, it did work. Look at that, that worked. Excellent, wow. That's coming apart really nice. Look at that. So, it's coming apart nice, but not on this top bit. I think the top bit might be glued a lot better. There we go. Excellent. Right, so the top bit wasn't good, but the rest of it was. Now, why are you not working? This is the low voltage side. I just want to see if it can pop out or not. There's no room to get to the side of the circuit board. There's a little clip here, a little bit sticking up here, so I presume this one here, it needs to come down from the top. It needs to come down from this side down. But what's happening is the gunk that's holding it all in. Let me measure this cap here and then I won't be worried about getting a shock. This is the big cap. Wow, 317 volts. So we've definitely got it going to there. So maybe the problem's on the output somewhere. anything there. Right, I'm going to have to drain that cap down. So the fuse and all this circuitry beforehand is going to be okay. So there's going to be a bridge rectifier and stuff on the other side. That must all be okay. Maybe there's a broken lead or wire somewhere. Maybe something from here, the transformer thing, has broken because of the impact, because it did have a serious drop. So that's why you've got to be so careful. I mean, that's exposed. You could easily put your fingers there, and there's 300 volts there. So just because this isn't working, it is partially working, and that would have given me a nice whack. Right, so in here I've got a load of resistors, and I'm just going to tap each bits of the lead, hopefully without shorting anything out. And it's going to turn. Why is that so hard to bend today? It's better. That's because I'm trying to bend it down inside. Right, so right now that 300 volts should be turning into heat in the resistors. Then I know it's going to be safe to work on. It's amazing because even right now you think nothing's happening, but there is. That voltage is being turned into, the energy is being turned into heat. Let's see if that's enough. There you go, 1 volt. So now I can touch it. I shouldn't have done that really. I should have put something like this on it first to make sure it's shorted, just in case. Like that. Insulated. Right, okay. I need to try to get this gunk off because the gunk's against the case. There we go, that was nice. And there, so now that should lift up. That thing is against the case here as well. There. There. The reason I like these power supplies a lot more is, well, power supplies are, I think, incredibly hard to work on, and I think most people would agree with that. But when it comes to this, there's much less components than on other power supplies, because sometimes power supplies might be giving out 12 volts, 5 volts, etc., while this is just giving out the 9 volts. There we go. There we are. So we know that these 2 prongs are working here because I fixed another power supply, didn't I? Where it weren't, it was arcing. So we know that that's working because it's going through. Now look at this, I can see a nice big burn mark here. Can you see that? It's all burnt around here. And that is above where that, oh lovely, look at that. Ah, wow, it wasn't dropped. The force of the capacitor moving up has blown this off. I thought the capacitor was sat high. Look how nice it fits now. Look at the bottom of this capacitor. Look at it. Look at that. So that should be the same height as this one, I think, but it's completely taken the bottom off. Now, is that the kind of rubbery thing on the bottom? It is. The whole board, that was a lot of force there. So, has the capacitor just completely shorted? I don't know if I've seen an electrolytic fail before, but that's what it looks like, doesn't it? Sorry, I've seen loads fail. I mean, fail as in an explosion way like this. I seen one ages ago where somebody put in a power supply the incorrect polarity and it blew the capacitor, the top off. But this looks like it's come from the bottom. As far as I can see, that is just the capacitor. Wow. Should we see if there's a short across it if I clean that prong up a bit there? They're just the output capacitors. Let's see if we have a short across them. Oh, I thought it was drop damage. I'm glad I looked at this. One ohm, but saying that then, why is it because this chip here has recognized that there's a short on the output? because it's not, you know, there was no bang or fizzle or anything when I plugged it in. Is this recognising that there's a short and it's cutting power to here? So even if I went across here, there's going to be a short now, isn't there? Yes, because it's on the same rails. So if I went across here, there's going to be a short. Yes, there is. A full short, yeah? So you hear it more now. Okay, let's try to desolder that cap and see if the short goes away. Or is the short on the board? Maybe something shorted and it's caused the cap to go. Maybe this is shorted here. Let's take the cap out, because there's no good anyway. Understandably, the solder doesn't want to stick to it. See if there's any way I can wobble that loose. Just trying to use a bit of leverage on it. Yes, got it out. There we go. Let's pull that apart. Let's see if we can see what... it's weird that the bottom came out rather than the top. You know what, I'm not sure if the short's coming from here, you know. Let's see now that that's out. I know it's a mess. But let's see if there's any... Ah, hold on a minute. Also, why have we got so many holes? We've got 4 holes down there instead of 2. They were vertically. Were they in vertically? Yeah, they were in vertically, which looks to be correct. Let's see if the short's still on the board. Yeah, short's still there. Full on short. So I think it's probably this thing that's shorted. This like rectifier diode, I bet. Okay, there's still a lot of carbon though. So what we'll do, how's that held in? So we just have an anchor point here and then 3 pins. Let's try to remove this rectifier diode, see if the short goes away, because I don't believe the carbon will be shorting that much. That might not have necessarily been faulty right now, but you can see it's expanded, so it's not. It's even if it's working, it's going to be highly stressed, isn't it? In the past. So I unsolder this rectifier diode on this heatsink. If it's on a heatsink, you can tell that it's going to be a component that's generating a lot of heat. So maybe again, this is a highly stressed component. Let's measure it out of circuit. Another nice one. This works so much better when you give it a good clean. So now it's just shooting up really nicely. Boom. I think I got all of them. Let's see if the ground one goes so well. Yes! Oh my word! I got them off as good as a desolder station. Oh, are you going to come straight out? No way. Oh, is there another? Oh no, we're just siliconed onto here. There we go. Unbelievable. You can see it's all burnt around here as well. So that would have been the heat, draining a huge amount of heat away, burning the board. Let's see now, do we still have that full-on short? No, we don't. So if we go to ohms, so I think that diode thing has, that is, if that is a rectifier diode, I think it's going to be, to convert the AC back to DC through the transformer. Where are we? Here and here. Remember, it was like 1 ohm or something before. There we go. that's fine now. So I have to clean all this up here. Now, let's see if you are shorted. So we have a full short there to there. Nothing there. Nothing there. Let's go to diode. And if we go here to here, yeah, that's a full short there. Let's go here to here. I bet it does measure a diode. No, okay. Now black in the middle. We still have a full short there. But I think we have a diode there. So I think this is a dual diode. Let's zoom in, see if there's any markings on it. Now, I wonder, I don't think I'm going to have any of these. Let's use a bit of IPA and see if I can get a read in from it. Right, it says JX, I think, is the manufacturer. SR20100 LCT. And if you have a look, yeah, that's 2 diodes, isn't it? So it's like a dual diode package. Let's see what that is. Don't think I'm going to have them, but I do have a few kits. You never know, there might be something in there. Well, I haven't seen if it's available. I don't think I'm going to actually buy one. It's just that whether or not I could take one from another power supply. If you have a look, it is a low VF Schottky barrier rectifier. 100 volts, forward current 20 amps. And the middle pin is the case, which it is, because the middle pin goes to the ground here. It says here that power pack, metal silicon junction, majority carrier conduction, don't know what that means, but it does say that for use in low voltage, high frequency inverters, DC to DC converters, freewheeling and polarity protection applications. I mean, we do have this here, so it's got the, it's got the information about it. I'm going to see if you can buy them. Well, I haven't spent long looking, but I don't know if I can actually get them for sale. Clearly they would exist, but I think it might be an AliExpress job. I'm just trying to work out the circuit. But what's interesting is I would have thought that maybe that was some kind of ground or something, but it's not. That is the actual positive output. Because if you have a look at the cap here, this is the positive side, this is a negative side. And the negative side goes to, the wire going down here, but it also goes along to that part of the transformer. So with the transformer, there's 2 little prongs coming down. So that's the negative one that goes straight to here. And then this one goes round to this side of the diode and this side of the diode, because remember it's a dual diode package thing, here and here. But it's actually this side that is the output. But the reason it's not coming up here is because there's a break. So it goes to this side here, and then because of all the burning, it goes to here. But if you look on this circular pad here, there's nothing here and here, there's a break. But yet if I go from here, it goes down to here. So that should go to there. So once that's flooded with solder, it will connect up again. And then this one will be the same as this one here, which is here, which will go down to the positive side here. So this whole metal bit is actually positive. That is your 9 volts positive here, this whole metal bit here. So yeah. Now, I know this little power supply doesn't deserve to be fixed, but it is nice to see something work again. So yes, I have bought the dual diode things from Amazon, and also I've bought the capacitors as well. When they arrive, I will pop them in, which for you will be a few seconds. So my capacitors have arrived, and they look to be the same height as the old ones, and also my diodes have arrived as well. I just want to check to see if we're getting a reading in diode on both ways. So this middle one should be in contact with here, which it is. So we are going to go to diode test, and we can go here or here, makes no difference. So we have a reading there and a reading there. Interestingly, it's not 0.6 because it's a Schottky one, so it's going to have a lower voltage drop. It's like half of that. And then if I go that in the middle, nothing there. And nothing there. So it is measuring a diode, both going towards the middle. Right, let's get these installed and see if this one can come properly back to life. 16 volt, 1500 microfarad. So I have to add new thermal paste, I get it installed, I also leave the legs long on the capacitor, and that way then I can route them via all the burnt out traces. So instead of me having to physically run wires, I'm using the capacitor legs by bending them into shape, flooding everywhere with solder, but make sure it's not shorting between the tracks, and I think we're going to be good to go. Now I know it looks a monstrosity, but I've checked it all really closely and everything is going to where it's going, and I'm using the legs of the capacitor to actually fix the tracks that were broken. So you can see now the middle one comes up here, not touching that one, not touching that. You can see it's well isolated, and it goes along that side of the capacitor to here and joins up right the way to here. So this is joining everything up along with this here. Remember, this is also connected to this this middle one here. This one is connected to this one, it's connected to that side there, and also the track's fine to there. So I've bent it up to that one there because the via is now gone, and there's nothing happening on the top. And this one here is absolutely fine. And this one I've brought through this leg of the capacitor and brought it around to here. So this is already connected through to these ones here, but now the via is connected to this one here, and you can see that there's no there's a bit of a black thing in the board there, but there's no continuity between here and here. That's completely free. So I think we're ready to put it together and see if it turns on. Right, here goes. Let's see. Is it going to explode? Plugging in now. Excellent. Excellent, nice and stable. Now let's bring the dehumidifier in and see if it can cope when it's plugged into that. Right, here goes. Is it going to fail now? So turn that on. So there we have it. You can hear it's whirring away for itself. So I'm glad I looked at that power supply. I always find them quite interesting. I'm now just epoxying it up, the brake at the front and also all the way around the edge, and then I have to clamp it together with the clamp and leave it a good long time. Like I said earlier, I wouldn't sell on this dehumidifier and the power supply, but if there was another dehumidifier in this job lot here or in the future that I couldn't fix, at least I know now that I can take the power supply off that one and put it on this one, and then it would be a safe product. But for me, it's always good to have power supplies because I know full well I will, even if I don't want to, come across more dehumidifiers in return boxes in the future. Even if my viewers don't want to see it, inevitably I will be coming across them again. So yeah, there we have it. It's all glued up. This power supply is absolutely fine for me to use, personal use. And yeah, I think it was quite enjoyable. Let's move on to the next one. Here we have one of these Smiley dehumidifiers again, a 1500 milliliter one. It's plugged in here, it's turned on at the back down here, and it's not making any difference at all. There's no lights, doesn't matter whether I put this in or out. Oh, hold on. Well, that's interesting. I didn't see that earlier. It says full, but only when we do that. So it's not, there is life there, but it's not on. But the switch is working. So it recognises that it's full, but it's not actually on. Interesting. Well, let's take it apart and see if we can see what's going on. When I did one of these in the Advent Challenge, it was the actual switch at the bottom was arcing on the inside and had burnt. But I can't remember what the fault was, whether it was this or not. Might be the same problem. Right, let's take it apart. Hopefully things will make more sense. So we have screws around the back and also two at the bottom here as well, which looks slightly corroded. So we know it's not a switch problem because there is life in it. I think it's going to be something to do. From memory, that switch that lets this know when the float is up to turn off, you know, where it says full, that has 3 wires going to it. And I bet you it's a faulty switch again. So I'm now going to undo these two and these two. So this is 2 Peltier plates on it. There we go. Right, I think we need to start here. So we know it's working when it's pressed in because something changes. I think it's not working now in that state there. So we're going to go to continuity. We have 3 contacts here. Right, so I think that we're going to have, so there's nothing there, nothing there, and nothing there. That's not right. Now when we put it in, we've got something there, but nothing there. So I think we should have a contact between the yellow and the red, which is the 2 at the back, when it's in this position here, and we haven't got anything. And that's the same problem we had before. So when I put it up here, it's recognising the black and the yellow are touching together. But why have we got the 3rd wire? So it's not doing anything there, it's not doing anything there. Yeah, so we've got a problem between the yellow and the red. And I bet when I take that apart, I bet it was arcing just like the other one. So let's take this out. And I have to get into it, so I've got it, it's got like this little rivet thing. So I'm going to take a picture because I'm probably going to end up snapping those wires off by accident. In fact, I might just unsolder them. Let's get a picture of that. Now, I'm not saying it is this, but can you see how things become much easier when you do something over and over again? The very fact of me having looked at this before, I immediately remembered that the switch was at fault. And maybe it's a common problem. Now obviously the easiest thing would be to buy one of them, but let's see if we can fix it. So I'm going to have to try to bend them in a little bit, and that will allow me to pop the pin out, and then it will allow me to separate these. I'm just trying to bend them up towards the middle, and that way then I might be able to knock the pin out. And then if I can fix it, when we put it back, we can try to splay it out again. There we go, pins out. I'm not sure, I probably broke most of the end of that, so I might struggle to get that back in. What I did last time is I just got my soldering iron and I burnt the plastic all the way around the edge. Here we go. Right, don't need to worry about the top. Then zoom in and see if we have the same problem as before. So I think it's the back 2 pins, and it's not going to be making a contact between here and here, which is essentially here. Oh no, it was here in the middle, wasn't it? No, hold on one second. When it's like that, oh, so it should be contacting between here and here. So we have here and here. Yeah, this must be the back. It must be just back to front as I'm looking at it now. So when we press it, I think these 2 work, but these 2 here do not work. So let's double check that. Right, so here and here. Right, hold on one second now. So, oh, it's here and here, isn't it? Yeah, so here and here, when we press it, works. But here and here is not going to work. So it should be working now, and it's not. Right, so last time it was, I think, this thing that had gone. Let's see if this is working up to here, which it is, and to there. But it's just not going to here. It's amazing. Look how well it's connecting. But look, there's nothing there. Yeah, it's here. So if I force down, it's there. Now I wonder if we just bend it a bit, would that be a better job? Maybe. Let's try to bend that there. Sorry, so where are we now? We're here and here when it's pressed. So that still works. And now that will work all the time. Okay, I think, you know what, that's probably easier than what I did last time, which was I got the grinding pen because I couldn't clean it with paper or anything. Let's pop that out just to see how bad the burning is. Oh. Oh, where are we? We're here. Oh wow, it's perfect. There you go, it's that tiny, tiny, tiny little bit there again. Look, just here. Look, just, can you see just here? Tiny mark. There, and it feels rough. There, I can feel the difference. This is like smooth, like an ice on ice skate, and here is just a little bit sandpapery. You can't even see it now, but it's there. I can feel it with my with the probes. Yeah, so it's been sitting on there and arcing incorrectly. I wonder, can we see anything here? I think I'm going to leave it this time. It might have just been on the very point of a point. So last time I tried to bend this, but that was a lot better doing it this way. Because last time I bent that, but this time we just bent this, and it appears to have done the trick. Let's give it another try. So when it's normal, it's going to be between here and here. And then when you press it, that breaks from there, so it no longer works. And then the light comes up telling you to, sorry, between here and here, the light tells you to change it. Yeah, so that's it working for 24 hours, 48 hours, the whole week. And then as it gets full up, then what's going to happen is this is going to do this, which is going to kill the power because the float's going to knock this like that. And then the light's going to come on to let you know that it's full. I think that's going to work. Right. Let's get it back together. So I put the two sides back together. I do melt around the edge just to try to keep them more closed. But even when it's together in the case, it's kind of sandwiched between two bits of plastic anyway, so I don't think it's going to go anywhere. And yeah, I just need to put the screws back in the back, and then hopefully I can show you it working. Now, will it be sad or will it be happy? I'm going to say happy. So plug it in, turn it on. Da, 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 da. On. Yay. There we go. Excellent. Full. On. Full. On. So as the water rises, this float thing here will go up. You can see it's now sticking up, and it will hit the switch and turn it off. Excellent. I was just about to plug in this little mini dehumidifier and I noticed that there was a bit of black gunk around here, and I thought, that's a bit strange. And then I put my finger in there to see what it was, and look at this. This just came straight off, and look at all the black in there. Let's bring it over to the mat and see what has happened. When I use the adapter that I fixed earlier with the loose diode on it, it works just fine. Again, it's another 9 volt 2.5 amp one. So they all seem to be, whether they're big or small, seem to be 9 volts 2.5 amp. Unless they've got the built-in power supply where you just put the mains in. But you can see here that the light comes on, I presume. Yeah, it's changing colours already. So it looks like this itself is okay. It is just this that's failed. Well, I wasn't expecting so many failed power supplies, truth be told. So it looks like it's come from this side here, not this side. So the secondary side's okay, which I suppose would make more sense. Unless, of course, it's just arcing where it's... But no, it looks like something's gone up in flames. Just wondering if it was arcing, but I don't think it would be this black. Now, how am I going to lift you out? There we go. Wow. That's pretty special. So those two prongs go onto the board here and here. The trace has gone right through from here. Initially I can't see what's gone, but there's a lot of, it looks like there's a lot of burn damage near the bridge rectifier. So I wonder, could it have been a short on the bridge rectifier? I mean, that is pretty amazing, isn't it? Can you see here? It definitely looks melted here. In fact, the traces are completely blown through. So let's get the multimeter out. First of all, let's see, has the fuse blown? Surely it has. So here's the fuse. Right, fuse has blown. Now, should we see if we can get a reading from the bridge rectifier? Look at that, it's gone here as well. And here. Right, well that's not shorted there. Not shorted there. Ah, shorted there. So it's shorted between one of the AC and one of the DC. So that's shorted. Let's swap the leads around. Make sure that that's still shorted that way. Yeah, that's shorted. I wonder, would this be possible to cause that amount of damage? And it's shorted there as well. So it's shorted from this side to that side of the DC, and AC here to that side of the DC. So it's shorted there and there. I am going to get some isopropyl just to humour myself, and I'm going to just clean this up a little bit just to see, is it just the bridge rectifier that's gone and the traces, or has numerous other things gone? I suppose what we could do is we could quickly test this here, this switching transistor. No. Okay, so a reading there, but it's not short. Let's go this way. No reading. We don't have any reading here and here. Oh, no. That might not be short. Let's clean it up. See what we're left with. Got gloves on because this is going to be so messy. But you can see it's all the primary side, not the secondary side. So a lot of this will just be like flame damage. So hopefully when we clean it off, we can actually see what components are burnt. Right, so something's come off there. Put that to one side, I don't know what that is. Well, I think that bit there is from that resistor. That one there. So that's also blown open. Right, shall we zoom in and see what we can actually see? It looks a lot better now. So you can see how much cleaner it looks. So this is where the probes go from the actual plug itself. You know, their contacts at the bottom here. and here, which go from here and here. You can see there that that's completely burnt through there. So that will go to there, and that will be, oh, here, that side off the fuse, yeah. So that starts the circuit on that bit there, going up to here, to that part of the bridge rectifier. And this one goes to that part of the bridge rectifier. So this one has actually stayed intact. And now this is blown through here, and this is pitted here. This is gone, this is a resistor. So this would be a, well, this is, yeah, this, well, it's not a fuse, that's the fuse. I'm not sure what this would be. Don't know whether that be some sort of current sense resistor, but it looks big. And I presume that's blown open, so that's not bringing it into the rest of the circuit. I'm curious whether there's any other damage, or is it just the beginning? You know, was it a big failure by the bridge rectifier and everything else is okay? So let's get the multimeter and let's just get a few little readings. Well, I'll tell you what we could do. We know this is blown 100%, don't we? Why don't we use some hot air, take this off. That's my gloves, just in case. And we can then hopefully get, you know, a reading on the rest of the circuit. Well, not a rest, but some other bits to see what's what. Now, it might not come off easy because it might be welded to the board. Thought it would be off by now. So the board might popcorn on me. Not wanting to come off. Right, that's gone molten. Yeah, the solder's molten. There we go. Right, it might be wave soldered. I can see two. Yeah, I think it's. I can see two pads there. Not sure. I can't see anything on the rest though. Yeah, it is. It's all wave soldered. If you have a close look here, can you see bits of red? And that's why it was so hard to come off. And you can see a bit of glue here, a bit of glue here. But this should be going around to here. But I think there's also a crack there as well. So let's just go to continuity to begin with. Let's see. We're going to have this to here. But do we have it to here? No. So it's broken just here. Yeah. So it's there, but it's not here. So yeah, that's gone there. That's why it was so hard to come off, because of the glue. Now, should we see if we have a short now? Let's go between here and here. I'll remind you, it's all broken, isn't it? Let's go here and here. No, I think we might be okay. Right, let's have a look at this resistor. Is it completely blown open? It should be. I would say that's probably the circuit. So that resistor's gone. Should we just check the diodes? Well, we're getting a reading one way and not the other way. That looks all right. Getting a reading both ways, but I think that's because we have a resistor going across it, if I was to take a guess. Yeah, and a massive diode here. You know, I think it's just the bridge rectifier and that resistor. Again, we're getting a reading both ways, but it's in circuit. I'm just going to check these resistors here. Oh, maybe we just need to. I think we've got it there, but we haven't got it on the actual board, so I think that just needs to be resoldered. Because if we zoom right in, I think with all the heat, I think it's just made this here not connected to the actual board, even though it looks just fine. So we need to find out what that could be. I have no idea. We might be able to copy another board. Let's see if we can get this one at least working. I am tempted to put a bridge rectifier on just to see if we can get anything out of it. Again, purely for the video. Just trying to burn away all the burning. And while I'm burning away the burning, let's give a shout out to the My Mate Vince Massive. The members this month are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pigsy, Russ Melanson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, and Garin Shaw. Massive thanks to each and every one of you. Now let's get back to burning off the burning. Right, that's the remains of the old resistor gone. Now it makes no economic sense to fix this. You might as well just buy another power supply. Looks pretty standard at the end here. I'm just doing this purely for the video. I'm thinking that the bridge rectifier was manufactured faulty, and as soon as it turned on, it shorted and drew a whole huge amount of current and blew. But I don't actually know that. So if we could put a new fuse, a new bridge rectifier in, and a new resistor, and if it started to work, and obviously I've got to redo a few traces, then we might have success. Because, for example, I don't have to just redo the trace here. I could just run a wire from here to here for the time being, wire from here to here, a wire from here to here. So bear with me. I want to see. I'm just going to get the other power supply. I want to see if there's a resistor after the bridge rectifier, and I might be able to copy it because I know the outputs are the same. I know that means nothing, but it might give me an idea about what size it should be. Well, it's very confusing. I'm a bit stumped. Bridge rectifier I haven't even looked at, but I think I'll be able to work that out. But it's this resistor that I'm stumped over, and the reason is because this circuit's lacking lots of things. Like, where's the X2 capacitor to stop noise coming back down here? You know, this one here has it here, and then we haven't got this choke type thing, but we have got an inductor which I think is doing the same job as this. So I'm struggling to find my way through the circuit, but I'm trying to go back from the these safety capacitors back, because that's where it's going across here. And the only thing I can liken it to, so I'm trying to work out what R10 is here, because you know the tops off it, I've got no way of finding out what that is there because it's in bits, it's all burnt off. But if I have a look here, we definitely have three massive resistors. Well, this is an even bigger resistor here, and I think they're using these three instead of one big one. And if you have a look, I'm thinking it's going to be a very, almost a dead short. And if you have a look, these are 1R60, which is going to be 1.6 ohms. But there's three of them, so we have to divide that by 3. And it looks like they're going to the leg off this switching transformer and then to the negative of the cap. And if we come on to this mystery one here, the negative of the cap is here, which does go to there, and the switching transformer is here, which, oh no, they're there. Hold on a minute. They're there, but look, they're still making their way over to the cap, aren't they? I'm wondering, even if I was just to put a 0 ohm resistor in, I'm wondering if it would do. But these are 2 ohm. So it's, right, what I'm getting at is, if we go from one of the legs here over to the negative of the cap, here we've got 3 resistors, which is 2 ohms. They're in parallel, so that's going to be 2 divided by 3. Let's see if we can just work it out. 2, I'm not saying it's the same circuit either. So that means that we're going to have 0.6 ohms across there. I wonder if I actually get that. Is that going to be true or not? Because they're all in parallel. Okay, yeah. Now, if we go across here, these are 1R60, so that's 1.6 divided by 3. So this should be 0.53. Remember, my meter's not going to be dead zero anyway. But you can see it's a bit more. So I'm wondering, let's just take the reading here. It's changed again. Maybe it hasn't. 0.84, let's see the difference. 0.84 and 0.7. I'm wondering if I was to put maybe a 1... No, I can't. It's got to be tiny, isn't it? I think I need like a 0.2 ohm resistor or something. 0.85. 0.77. 0.15 difference. 0.15. Yeah. So I need to get a big beefy resistor, I think. That's like 0.15 ohms or something. I might see what I've got, because this is just purely for the video, just to see if we can get something out of it. So as you can see, there's quite a lot of work to do here. Now, this could be a video in its own right because there's that much to do, but obviously this is a JOBLOT video, so I'm just going to whiz through it. I believe it needs a new fuse, a new bridge rectifier, it needs a new beefy resistor, which is going to be something like 0.2 ohms, and also that little resistor that I tried to solder earlier, I thought it was just very burnt and dirty on one side. It's completely burnt away back to the ceramic or whatever these little resistors are made out of. So if I was to go across the very top of the resistor, I can still get a reading. I think it was in the megohms from memory, but when I actually go onto the pads at the end, there's nothing there because it's been burnt away. So I also need to change out that little resistor, and I need to redo various different traces around the place as well. I actually use some solder wick for the solder wick that's full off solder for these bottom ones where they want to make a contact with the pins from the actual case, you know, the main AC pins coming in, because I need something quite beefy there, and also I need them to be quite fat so they fully make contact with the pins coming in. I don't want them to arc, so I think solder wick's quite a nice little thing to use. Now, this looks a complete and utter mess, and I'm not arguing that at all, but I do actually feel relatively safe doing this. I will of course be plugging it in outside because that's just me, but I wouldn't be doing this if I thought it was actually going to go up in flames, but I don't know for certain. Please don't copy what you see in my videos. Nobody in their right mind would be fixing up this power supply. It's just interesting when we see something so burnt and so far gone where most people would say that's unfixable. Can we get voltage out of it again? Remember, it's purely for the video. I'm well aware that you can probably buy this for £10 and nobody would be, you know, I'm going to end up spending on parts near enough that amount of money. Well, I won't, to be fair, but time most definitely. But I just think it makes for a more interesting video to try to get voltage out of it. So this could really be a video in its own right, but it's not. It's part of this video here, so I'm having just to whiz through it. So let's plug it in outside, and let's see if we're getting any voltage out of it. Fingers crossed, we might be. Right, I've got this outside. You're not going to see a huge amount because it's dark, but I've got a tiny little torch here. My daughter's taken my big Milwaukee one, which I'm missing massively. She keeps forgetting to give it back to me. I am going to now go inside and I'm going to plug in the actual extension lead itself. And so then if it goes bang, it's out here, it's on the concrete. Yes, this may melt, but I think it's unlikely. Once I unplug it, power's going to be cut. I wouldn't be doing this unless I thought it was going to work, but clearly what I've done is very bodgy. But I just want to kind of see if we can get voltage out of it, just to see if something this burnt can actually come back to life in a zombie apocalypse type way if you had no other chance of buying a power supply. So I'm going to plug it in now and we'll see if it goes up in flames. Right, it's plugged in. I haven't heard any bang. I'm going over here carefully. Now let's get this and see if we're going to get any voltage out of it. Not even sure if you can see any of that. Let me put the light on. Might be able to see that. I'm not sure. I'll hold it up anyway. Right, here we go. So, outer pin. Come on now. Middle pin. No, we're not getting anything. Ah, I would have thought that might have worked. No, all that hard work for nothing. I wonder, is everything blown on the inside? There's nothing there. Let me just double check this is actually on. Yeah, it's definitely on. Oh, what a shame. Part of me wonders whether or not it's not making a contact. Yeah, okay. Just take a quick look inside, leave the setup here, just in case it hasn't made a contact. I was expecting it to go bang or something. Silly me, there's no continuity between the DC side of the bridge rectifier up to this resistor because there's a break in the track just here. And I knew about that, and I meant to scrape it back with the grinding pen and solder across it. So I'm going to do that now, and then we should have power going up through here. Then hopefully, at least we'll get some sort of bang out of it. Right, have a listen now, up to the resistor here and through the resistor. So now 100% we're going to have it through the bridge rectifier into the circuit. So I'm going to do rinse and repeat of what we did before, and let's see if it's working. Right, this time, now, I'm still unplugged inside. So let's plug that in here. Okay, the camera will pick up whether it's going to bang or not. I'm going to go in, turn it on. Right, I haven't heard any explosions, so let's see now. Are we going to have 9 volts? Please, please, please. Please, please, please. Yes! Yes, yes, yes! 9.4 volts! Look at that! Unbelievable! And stable. That's crazy. Wow! That's so good. Right, I am going to be brave enough to bring this inside into the kitchen. Let's plug in the dehumidifier, just to see it working. Now, fair enough working with just no load. Is it going to work with load? So this is live at the moment, so let's plug it in. We are in. Now, is it going to go bang? Not yet. Turn it on. Fantastic. So I think it was the bridge rectifier that then took out everything else. Is that working down the bottom? Yes it is, yeah. Yeah, it's different power. Well, I think L2 is the biggest power. So yeah, there you go. I don't know if you can hear that. Hopefully you can. It appears to be working. Obviously this is not going back into service. It was just a bit of fun messing around with it. But yeah, I think we proved the fall. I'm going to say bridge rectifier. Now we have a bit of a beast of a humidifier here, and it's completely dead. So I've got it plugged in. When I turn it on, nothing's happening. Let's bring it over to the mat and see if we can work out what's what. Right, first things first, I want to see if the fuse in the plug is okay, because this thing's completely dead. No. Okay, so I think the fuse has gone in here. Three amp fuse. What watts is this, I wonder? It is a 60 watt, yeah, so 3 amp is absolutely fine. 1 amp would be fine, because that would be 240 watts. In the UK, standard fuses are 3 amp, 5 amp and 13 amp. So let me get another 3 amp. Let's just make sure it is the fuse and not something dodgy with the plug. No, so the fuse is gone. I wonder if there's a short in here then. No? Strange. Right, I got my 3 amp fuse here. Just going to make sure that these are tight. which they are, and they're the correct way around. Live going to the fuse. Right, let's plug it in. The fuse may well blow again, because what caused the fuse to blow in the first place? Here we go. Whoops. Plugging it in now. Is it going to bang? No. Oh, it came on for a second. Oh, it's blinking red. Right, okay. What can you see? Let's unplug it because we don't need that plugged in. Blinking red means that it thinks it's full. Yeah, it's still it's just got charge in because the main capacitor must be charged up. Blinking red means it's full, and if you have a look here, this is the water container here. Oh, what? We've got another lead here. I wonder, has the fuse gone on this one? I was thinking it was strange that the fuse has gone. I think the fault here isn't the fuse thing. This must be off they must have added a lead from another device. Yeah, that fuse is okay. I'm not quite sure what we got the pipe for, but anyway, you see here there's a float thing here. So when the water fills up in here, this lifts up, and then it will. Oh, so it actually brings it down, which is interesting. Ah, so it brings it down. So this should be closed, and then as the water, yeah, should be closed, and then as the water goes up here, it's going to open down, the opposite of the other humidifier we did earlier. Anyway, have a look at that switch there. Can you see what's happened? It's completely bent over. So it's not working. So when this was pushed in, it must have caught this, or maybe they pushed this up a bit high, or from maybe when it was made it was a bit low, and it's caught it and brought it down this way. So let's see if we can fold that back. So we want that to be closed and then opened when the water is full. May have to take this apart. I'm not sure if I'm going to be able to bend this into shape. I wonder, would that do? Can't hear it clicking. Let's get rid of this. I think it needs to... You know what? It doesn't seem to click at all. Let's plug it in and just mimic the thing in there and see if we can get rid of the red light. Okay, now. So we want it to be closed. So it doesn't make a difference. So that switch is not working. I think we're going to have to take it apart to get to the switch. There you go. Switch is working, but you have to really force it up. Well, I think I would be wise to take this apart because much more bending, and I've got a feeling that's going to break. And if it breaks, it's going to need replacing. So I've got two Peltier plates here and here. I'm wondering if you have to take this off at the front. Yeah, I can see a screw underneath here. Ow! Ow! Well, that's annoying. Oh, that was done with plastic as well. That's going to be an annoying paper cut type thing. It's one of those ones that's hardly bleeding now, but give that another minute and I bet it's going to be pouring out. It is, however, clipped in. You can see clips here. Well, I'll just use some sellotape at the moment. I'll get a plaster in a bit if it gets bad. It's actually very easy once that first one's popped. There we go. Excellent. Right, that's uncovered screws all around here. So let's undo them and then we can have good access. Even now I've got much better access to here. Much better. Here we go. Excellent. Right, we are free. Well, that all looks lovely. That's brand new. Look at that. It's nice. Look at the way the bridge rectifier is put on at an angle. I mean, it's soldered up, I can see underneath, but it's not very nice, is it? Circuit board looks nice. Plenty of space, though. Right, I don't think I have to stress too much about undoing anything, because I will have access here, will I not? Oh, 2 more screws. So you can see the Peltier plates are energized from here, link cable to this one, and then over to this one here. So it looks like they're in series with each other. And when you put power into them, then one side will get extremely hot and one side will get extremely cold. I am just going to unplug that there because it's putting a bit of strain on that. And we have the fan there to keep it cool. Yeah. Right, okay, now we have access to this switch at long last. So, can we bend this into place? It's been glued in here, I might have to undo that. Can we get it out? Yes, okay, there we go. Right. That is very, very, very close to breaking there. So unfortunately, because it was bent at such an extreme angle before I even took it apart, there's like a fracture point on it. It's not broken yet, but you can see that vivid line. I don't think it's going to take long for this to break. So I think we need to glue some reinforcing metal across it. Obviously, you can just buy a new switch. You know I'd be able to do that. I just need to solder one in. Let's see if we can fix what's already here, because it might make a more interesting video than just buying a new switch and soldering it in. Right, I am going to, in this instance, I think I'm going to glue a bit of metal across here, and that will just give it a bit of strength. Could even do it underneath as well. Just looking around to what I can use, and I think this here would be perfect. Got quite a few of these. Let's see, is this going to cut through? Yes. Do you know what? I'm going to crush the end. And I think I'm going to fold it over so I don't cut myself. That'll be okay. Full of cuts by the end of the day. Right, so I'm thinking if I could cut a bit, put it on here and fold it over, then I'm thinking that will be a bit of a lasting fix. Lengthwise, what do we need? A little bit less than that. And we need 2 of them, but it's coming up a bit, but it don't matter that it tapers. So if I was to do it about there, wonder, would spot welding be a better job? That would be a bit, would that be too thick to spot weld? Might work. I think it'd be more satisfying, wouldn't it? Shall I try to spot weld it? Hoping this can spot weld. So I want to bend that over to so that way I'm going to crush it, and then I need to open it up again. You know, this metal is so strong, I wonder if I could just bend it on and crush it down. I don't think it's going to be going anywhere. Right, that's it there. Got a bit of my homemade plaster stuck in it now. It's not bleeding bad anyway. So lift it up, if I can slide that on. You know, to cover that crack. You know, even at that, I don't think it's going to go anywhere. Can't seem to get the last bit on for some reason. Wow, I think that's a pretty good fix even as it is. Now I could try to get a little bit of glue. Do you know what? Spot welding? I think the viewers would like spot welding more, but in reality, if I just got some super glue, very liquid stuff, and let it seep in there, I don't think that's ever coming off, because even now it seems to be on there very good. What the viewers want, the viewers get. So let's get my spot welder charged up, and let's see if we can do a permanent fix on this little switch. Right, I think the voltage is enough to make this work. We've got 5.5 volts. I'm wearing safety glasses, which are annoyingly scratched really bad, so I can barely see through them. You can see now 5.5 volts. I've got it to 20T. I don't know what I need because there's not enough here to practice on, and I've got the foot pedal down there. I'm really finding it hard to see. The reason I'm wearing my safety glasses is because I've got a feeling that this may spark everywhere, because I don't know what this is. I'm thinking it wouldn't be stainless steel. I'm thinking it's just going to be steel, but I don't actually know. So here we go. I'm going to line up. And there might be a big spark. Let me get my foot. Honestly, I can barely see the floor. Right, here we go. That was as weak as anything. Let me try a little bit harder. There's no way that penetrated. Let me go further down here so I can get more pressure on. Wow, that's so weak. Let me go right the way up. Maybe it's not conducting through this very well. So I am going to go to 40T. ever know if I've used it that high before. Gee, dearie me. Wow. Okay, well good job I had my glasses on. Well, I think if it was going to have gone through, I think that would have gone through, but I don't really know if it's just sat on the top or not. Well, certainly it's amazing. 20 did nothing, 40 was like boom. Let me try 30. I might do a slow-mo on that. I think it probably looked quite nice. Let's see if 30 is more controlled. It could be the material. Well, you know, it might have gone through. I just wouldn't mind one in the middle there. I think I'm going to have to use a grinding pen on it to make it look a little bit better. Because this is visible. I should have used glue, really. Right, I'm going to call it a day at that. But I can't say with certainty it's gone through. But hopefully it has. I think I'm going to get the grinding pen now, because it doesn't matter if I take a bit of the burning off it, because, you know, it should be the weld that stuck the metal together. So I'm going to turn this off. Right, I'm just going to use the grinding pen just to try to neaten it up a little bit, just to get rid of the black marks. I'm thinking if somebody looks in here and it's kind of more silvery, I don't think it's going to look as bad. Oh, I think that looks better. Right, well there we have it. I don't think that's going to break. So let's try to get it back in its home. I think even without the spot weld, I think that was going to hold. Probably should do belt and braces and put some super glue on it. I'm sure it's going to be fine. So there we have it. I quite like that little repair there. Of course, when I take the blue tack off, it pulls off a wire with it. So I just have to resolder the wire back on, put it all back together, and then I should be able to show you this working. Right, let's see now. Is it going to make that nice clicky sound? So this will go in like so. Clears it nice and easy. And yeah. So we've still got, after the click, still got that. I think that's enough. Oh, you can see a water fill indicator from the front of the machine. Imagine if I put it in that bent straight away. That would be soul destroying. Okay, let's use the same plug that we did earlier. I've got a spare lead now as well, which is nice. And plug in and turn on. There we go. See the lights there? Oh, and we have a red light here, so I presume that's going to cycle through different colours. Or maybe it is just red. Let's see. In the meantime, do this. 8 hours, 12 hours, 24 hours, then off. Okay, nice and straightforward, and this must be, I think, lowering down the fan a bit, I would say. Or, no, maybe it turns the light off. I think the fan's increased. As far as the light is concerned, I think it's just red. Oh no, it's going to pink. It does change colour. But there we go, pretty sure that's fixed. I'll find part of the house where I can put it in where the sound doesn't annoy me. You can see it going through different colours. Yeah, I do like the look of this one. Well, I've just brought this downstairs. This was upstairs, but every time you hit the light bulb, it will go a different colour, and I think it stays on that colour. but then one of them will cycle through all the colours. So if you like blue, you could just leave it on that. But then I think it's this one that starts off red, this one here, that will cycle through the different colours. Right, it has actually collected a good amount of water. But my son had a shower, so that's going to help. But you can see there, hopefully you can hear. So there is a good, it's harder to see in this one, but yeah, I can hear it splashing. So when I say a good amount, you know, a couple of teaspoons. Right, but yeah, I do like that one. Do you remember I did this one here and the lead had a blown fuse in it, but then I found there was another lead and a tube in this one here. Well, anyway, this one here didn't come with a lead, so I used the lead that was found in this one here, and as soon as I turned it on there at the wall, it went pop inside. So clearly there's some short on here, and the lead on this one must have originally been on here because it blew the fuse. So I'm pretty sure now the fuse will also be blown on this one, or maybe not. Maybe this time it took out the fuse on the inside, but it was definitely a pop. So there's something seriously wrong with this one. Let's take it apart and see what's caused, if it is the fuse inside that's gone, what's shorted that's caused that fuse to go. So first of all, let's see if the fuse has gone from here. Yes, so the fuse is blown. Okay, I'm pretty sure the pop was coming from here, but anyway, even if the pop was the fuse, something's causing the fuse to blow. So let's take this apart and see what's going on. Can I hear something? I can hear something on the inside. This might not be fixable, or it might not be economically fixable. It's amazing how much easier something is when you know how to take it apart. See there, because I did it with confidence, I didn't cut my finger or my thumb or anything, and it came apart really easy. Right, let's undo all the screws. I hate to admit this, but my special screwdriver, that in my mind has never let me down, but it might have done, I might have blocked it out, is really struggling. And when I took apart the last one that was like this, it came apart no problem. The screws might be a little bit, yeah, I think their heads are a bit smaller on these ones. It's managing, obviously, because it is the world's best screwdriver, but it's struggling. The world's best because of course I made it. Right, let's see what is rattling around on the inside. Oh, there's one at the bottom, isn't there? Right, I presume it's something to do with the main board here rather than here. So what's rattling? Oh, I can see a resistor's blown. Oh, there's quite a few things blown. Oh, okay. I don't think I'm going to be taking this any further. Let's just carefully take that out here. I wonder, it must have just been the bit of resistor that was rattling. Yeah, there we go. See it here. In fact, I think that's that thermistor thing. You know, that NTC thing that changes resistance as it heats up. Right, let's see the failure point. I'm not buying a load of components for this. Just want to be careful that I don't shock myself. So let's try to take this board out and measure that big cap. Trying to touch the low voltage side. I'm struggling. Whoa, jeez. That's what you got to be so careful. If I had shorts on there, it might have got me in my privates. Right. Hopefully there's nothing in the big cap anyway, because I don't think it would have got that far. No, dead. So this is safe to work on. Right now, let's see what's going on. Let's zoom in a bit, and we'll just use continuity. So it beeps. Let's just see what the problem is. So it comes in here. I presume this fuse has gone. There's a little fuse just here. So let's measure underneath it. Right, so fuse has got, no, fuse hasn't gone. What? Fuse hasn't gone. Okay, you can see that that resistor there has gone. So if we were to go to ohms, should we see what's reading now? So to me, that's open. I'm thinking that might be just a board itself. Right, you see this little thing here? That's completely blown. So let's follow the path in. Let's go back to continuity. So from this side here, this is the, I presume that's going to be the negative. Goes to here, goes through there to here, and then it goes through this thing, which I presume is no longer going through. No, so that is, what? It is 15 ohms. It is going through there. Okay, well let's go to, and then where do you go? You go up to here, to here, to here, through this, and then you're going through all the bridge rectifiers, which then goes to the cap, but we know power's not getting to the cap, so we'll check the diodes in a minute, because you can see there's 4 diodes there, so that's changing AC to DC. Let's just try the live side, here, 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 up to here, and then into the diode. So the only thing I can think of is that the diodes have gone, but they look perfect. I know that has gone, but it does seem to still be conducting. Also, can you see here, unless, I wonder, did this go short? Can you see here, this resistor's blown as well. That's gone all black or brown. $40 ohms. Still got a 40,000 ohms. Still got a reading though, but I don't know what it should be. I wonder, has this thing gone here? We'll come back to the diodes in a minute. It's just they don't look blown. Let's go to diode test. Black in the middle. Nothing there. That looks like a short. Yeah, we got a short there, but I don't know if that's necessarily on. And that looks like it's open. I don't know, I'm not sure 100% if that's the board, but it looks like, I think maybe that's blown, which has taken out the resistors. And also taken out that as well. So there's a lot of components here that's gone. Let's go to, we're on diode test. Let's just see what's happening with this. So that's shorted. That's definitely shorted. Let's try this one. Nothing that way. That seems to be okay. Let's try to reach in here. This one seems to be okay. Yeah. And that's shorted. So those two are shorted. I wonder, are they on the AC? Hold on, this one. This one's coming up definitely on the AC. And so this is the DC one. But that's not. Are they both going the same way? No, they're not. Okay. Well, I suppose the first thing we'll do is, I'm pretty sure they're going to be gone. So should we just cut them there and then see what happens, or should I unsolder them? I don't think I'm taking this board any further because I think there's quite a few things gone on it. And I've already bought spares from Amazon. I'm not going to buy more and more and more and more spares. I'm going to cut this and cut this. I know now if they're working I'm going to struggle to get them back on, but I'll hopefully manage. Let's see now. That is lazy, very lazy. Let's see if the short's still on here. Yeah, so it's the actual diode itself, and on this one, it's the diode itself. So those two diodes have definitely gone. Let's see if the short is still here on this one here. So it was between these two, wasn't it? Yeah, so that's still shorted, you see. So I think that's gone as well. Might unsolder that just to test that out of circuit. And I think the resistors are probably gone. So I'm going to whiz through this now. Yes, I do unsolder that switching transistor thing, and this is what is testing out of circuit. Well, that came out pretty easy. So let's see, is this testing faulty out of circuit? In fact, to tell you what we'll do, let's just go to continuity. There you go. So the fault's between them two there. You can see a full short. Now let's see if we have anything on this side. No. No. But a full short this side. Right, okay. So we would need minimum this, two diodes, and one of these to potentially get this working again. Now I do have a look for my spares, because if I had spares I would pop them in. You know, it's always nice to see something work, as I've said many times in this video. If I had this item first, I would have got spares for this, and my time would have been better spent on this, because at least it's going to be a working, probably safe dehumidifier to use. I spent ages on this video working on tiny little power supplies that you can probably pick up for £5 to £10. But anyway, it was just the order of events that I looked at things. I really should be fixing this, but this video is long enough already, and I've already done so much work on power supplies. I don't want to buy more spares and spend more time on another power supply. So I'm parking this one to one side. I could possibly look at it again in the future if I have another dehumidifier like this one, which is a good chance I might have, and then I might be able to use spares from that one to fix this one, or this one to fix that one. So it might come in use in the future. I think if I was to get the spares that I mentioned, I think this probably would work again. If I had to take a guess, I would say it's a switching transistor that failed, that knocked out everything else. But you put down in the comment section what you think. Could it have been the diodes that failed that took out the switching transistor? So yeah, I should really be fixing it, and if the video was shorter I would. I do believe this one can be fixed, but I feel like I've done enough power supplies in this one video. So yeah, apologies, I'm not fixing this one. Right, this one is in very good condition, and it came with an adapter. I plugged the adapter in and nothing's happening. Now I don't know if it's an adapter problem or whether it's a dehumidifier problem. Let's bring it over to the mat and see if we can work out what's wrong with this one. Now, is it the dehumidifier, or this here? So this should be outputting 9 volts, 2.5 amps. So maybe that's a kind of standard thing then for dehumidifiers to be that voltage. This is just like a normal one, not like that weird square one. Presume it's centre pin positive. Yeah, we've got it there. Interesting. So it is a problem. Jumping quite a bit though, isn't it? Hold on. That's not me. I don't think that's right. That's all over the place. Yippee! Lucky me, we have yet another power supply fault. Let's see if we can get into this one and work out what's wrong. As you can imagine, it's a nightmare to get into. It needs to be a nightmare to get into because otherwise it could be dangerous. If it was easy to get into, somebody might accidentally drop it, plug it in, go to unplug it and then electrocute themselves. So I'm using the vise with various different implements to try to put pressure on it, to try to
break the seal. It's so satisfying when you hear that crack where you know the plastic's separated in two. That way then there's a slim possibility you might be able to glue it back shut again rather than having to saw your way through and rendering it completely useless. As always, don't copy what you see in my videos. You shouldn't be fixing these power supplies. They're dangerous. I'm not going to put this one back into service. Just take it purely for entertainment.
There we go. Yes. Yes, 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 yes. Fantastic. Right. There's going to be quite a few scrapes on it, but I don't think it's awful. I don't think I would have been able to do that without the vise. Right, so this is the main income. And I've got to be careful now because this may have voltage in it. I can see a 400 volt cap. Let's measure that and see if it's discharged itself. I think it will have because this is working partially. 2.8 volts, so I'm happy to work on that. Okay. You can see that they've got two prongs here that you can use instead of the wires. You know, if there was prongs coming out the back of here like the other power supply. Here we go. What's that there? That's stickiness. Now, you know what I'm wondering? Do you remember that lamp that I did, the desktop lamp, that kept counting up the voltage? I know it's not doing the same, but the voltage is all over the place. I wonder, is it that little chip there that's gone? This little one on the secondary side. It says 9AV on it, but that's not what it's called. I forget what it's called now, 4 something. Or could it be the capacitors here not doing what they need to do? They're not smoothing the signal out. I think we're going to go straight to that little chip and see what it's testing on. Let's go to diode. We're reading there. No reading there. Might be normal. And a reading there. Swap leads. Reading there. And a reading there. There's no short, but we have a reading on that one there and no reading here. Oh, we have got no, but yet on this one we got a reading both ways. We have a reading that way and a reading that way, which may indicate, I'm not sure. What would cause that voltage to do that? Not stable. That must be wide on here. Let's check for continuity just to make sure. Well, actually, let's leave it on ohms. Let's make sure we have a nice short reading in case the cable's iffy. So there you go, under half an ohm. So I'm going to go on here and here. Yeah, so that's fine. And let's go inside. And here. No, so it's not the cable. I suppose we could zoom in and measure some resistors. So this is another one that in real life actually takes me quite a bit of time. I know it's something to do with the feedback. I mean, it's kind of working, so all the primary side must be working. It's just that we're not getting a stable voltage out. It's fluctuating all over the place. So in my mind, I'm thinking it's something to do with the feedback. So in other words, things to and from the optocoupler. Anyway, after looking at various different things, look at what I find, and it's just kind of by fluke that I find this. I'm not even sure if a visual inspection would have really shown this up.
But it's important, listen to what I say and look at my multimeter, and then this does actually pinpoint what the fault could possibly be. I mean, I suppose we could just test the diodes around the place. I think the reason this is going to be so hard is because it is kind of what it's, you know, it's working. It's just under load it's not working. So I'm getting a reading both ways, but I think that's just because it's in circuit and now it's gone. So I think that's okay. So with a diode, I'm expecting a reading one way, but not the other way. Oh, hello. Oh, nothing here. Ah, I've got my hopes up there. Yeah, I just have to stab down more. That is it for diodes. I'm just looking through my eye loop here, and there is something I've seen. I think it is making a contact, but it's definitely lacking solder. Have a look here and see if you can spot anything on those components. If you said that the diode isn't soldered here, you'd be correct. Look at that. But it is on there, but you can see that's covered. So what we'll do is, let's go here and see if we have a diode test. Because remember I said I didn't have a reading. Maybe by me pushing down on that, that was the one, wasn't it, where I got my hopes up. I'm actually excited now. I think this might be it. So let's go on to this one here and here. And we have a reading. No, that's bad. But we didn't have a reading when we first went on it. I'm wondering, let me see if I can lift it up ever so slightly. I wonder, did I force that down, which made a contact? I'm not sure. Giving the reading all the time now. It probably is fine, but it's something I've seen. So let's put solder on. You never know. It seems a bit of a coincidence that that's the one I wasn't getting the I got my hopes up on. Right, you can see that's definitely covered now. Let's pop it back in and see if it's done anything. Imagine if it had. I don't even know what that diode's for. Right, now. Come on. We're in. Come on now. Come on. Come on. Hallelujah. Yes, Vince. You did it. You did it. Amazing. It was visual inspection though, but the multimeter didn't lie. the multimeter picked that up, but then when I forced down, because you have to press down hard on these, and by me pressing it down, I've pressed the diode more into place. But that's it. That was it. Fantastic. Okay, I think that was a bit of a weird one, and you can see why I thought it was the feedback. But let's have another look at that diode and see if we can work out. Well, I'm not going to be able to work out. When I say we, that's the royal we. You guys are going to be working it out, because I know I don't know what that diode's for. Oh, that's so good. Ah, look at that. I don't know why I get a kick out of it being unplugged and still having the voltage there. Also, it lets me know that the cap inside is drained, but I like that. I know you can't. I know you can't. You know, make energy. You're just changing it from one form to another. But there's something nice about storing energy in a cap when it's not a battery, but it's still producing energy now, even though no energy is going into it. Again, something as a kid I think I would have liked to have played around with to, you know, I actually did technology at school. I did design realization, design technology, and design communication. So communication was drawing, design realization was all like the woodwork, more metalwork based things, and design technology was the electronics side. But there was only five of us in the class, and the teacher I really liked, but he was too easy to, nobody did any work. And then we got a police officer, ex-police officer, who was really strict and was shocked that we didn't know anything, because the previous teacher filled out something to say that he's taught us everything, but nothing sunk in. And then with him, all you'd have to do is you'd work for about 5 minutes and then say, "Sir, what was the scariest time you had in the police force?" And then you'd hear all stories, and he talked the whole rest of the lesson. Terrible for learning, but great teacher. We had such a good time in that class. Now, this side you're going to a resistor. It doesn't look like you're doing anything there. This side you're going to a resistor, but you're also going around here to the 0 ohm one, which is going through here, which is something to do with the startup capacitor, which is going through to, what's here? This is the chip. So look, the diode, this side anyway, goes here, through the 0 ohm resistor to this track, goes, I think, through there to here, through the 0 ohm to here. And I bet that's something to do with the feedback, and that's why the feedback was all over the place. But it was this side that wasn't actually connected, because I presume this side is probably ground or something. Oh, it's going to the transformer. Yeah. Okay, if you could put down in the comment section actually what that does, because I don't know, but clearly that's what the thought was. Oh, I enjoyed that immensely. Right, I am going to try to just glue this up for my own needs. I'm just, I promise I wouldn't be selling this on, because obviously this here is damaged. But I'm going to glue it up just for my own needs. It's useful to have different adapters. Also, if I come across other ones, it means I might be able to fault find it using parts from this one as well.
Now, I left this overnight, and you can tell it's been chewed at, but it's not too bad. Something I'd happily use myself. Now, let's see. I haven't actually plugged this in yet. Let's see, is this going to come alive? So turn it on. Now, are you going to be stable enough? Excellent. Fantastic. You can see the LED lights shining at the bottom there. Well, that is a result. And you can see the colours changing. Now, we'll have to do further testing on the actual dehumidifier, but I think it's going to work fine. The fault was with this. I thoroughly enjoyed that one there. It was a bit of a chase to get there, but I really enjoyed that one.
So there we have it. There was one more dehumidifier, and this one looked like it had smoke damage. It is working. You can see the state of it here in this part of the video. This is just a voiceover. But this one didn't come with a power supply, but when I use another power supply with it, it works. The problem is, look at the state of it. So this isn't burnt itself, it's like smoke damage, so it looks like it's been involved in a house fire, unfortunately, and the whole thing is black. So you would need to strip it all down, you would need to clean the circuit board with some isopropyl alcohol, and you would need to wash all the plastics in a bath to hopefully get them back to white plastic again to get rid of all the smoke. Even then, I'm not sure whether it would always have a smell to it. I don't know whether you'd be fully able to get rid of that smoke damage. I hope nobody was hurt in this fire. Maybe it was from a faulty power supply. I mean, we've had quite a few faulty power supplies in this video. So could it have been that one of those went up in flames and then caught fire to some curtains or something, which then, you know, this thing has been subjected to a lot of smoke. But hopefully nobody was hurt. Let's finish up the video now in the kitchen.
Well, there we have it. If you're not sick to death of dehumidifiers, there is something wrong with you. Whoa, we got through a lot there. But you know what? 8 out of 9 is not bad. And even this one here, I do believe is fixable if I was to buy those 5 or 6 parts. So we could have had 9 out of 9. One of them does need a thorough clean because it looks like it was involved in a house fire, but I don't think that's going to be interesting for the video. It just looks like there's black smoke everywhere. I think there was some really interesting fixes there. I thoroughly enjoyed it. I know the video is extremely long and I know it's not going to get much views because it's dehumidifiers, but I think when it came especially to these little power supplies, I think that there were some interesting little ones going on there. I think my favourite one probably was the diode that wasn't soldered onto that bit there, because it fooled me with the multimeter, because when I pressed down it suddenly started to make a connection, but then when you look closely you realise that it wasn't soldered. So I think that was probably my favourite one because it was unusual seeing the voltage fluctuate like that. So again, I thought it was feedback, but it threw me for a bit, but we got there eventually. I really enjoyed it and I hope you did too. So thanks very much for watching and I'll see you again hopefully very, very soon. If you did get fun out of this one, give it a thumbs up. It does help the channel. If you haven't already, subscribe, and fingers crossed I will be with you again in another few days to a week. Thanks for watching, everyone.
I went out and tried to cut a pine tree down, fell through the ground like Alice. Oh, what a sound. This must be a nest. I got rocks and sticks against my chest. I'm Alice. Dear Queen of Hearts, I'ma grow you white roses so you can learn to be kind. Tell King of Hearts to arm all his forces so you can learn to be kind. What a start. Inside out and upside down. No stress, I'ma clean up this mess like Alice.